Good morning, dear friend. As you see here, the topic is triple point. So, before I'm going to explain triple point, we explain some technical terms which is helpful for deep and clear understanding about the triple point. So, let's start. First term is phase. You know phase. Generally, you know phase. A substance has three phases. First, solid. Second one is liquid, and last third one is gas. So you know here the three phases of any substance: solid, liquid and gas. Second term is coexistence. That means a substance which is exist in solid, liquid and gas is known as the coexistence. That means at the same place and the same times. Notice that same place and same time. If any substance found in three phases, solid, liquid, gas, at the same time and same place, that is known as coexistence. And you clear about further we explain the figure, then you clear about what is the same place and same time, so don't worry. Now third term is thermodynamic equilibrium. So it contains three parts. First part is mechanical equilibrium. So there is no unbalanced force within the system, between the system and their surroundings. Notice that no unbalanced force. That means force equals to constant all around the system, within the system and between the system. Suppose that you let two systems, here first system and here second system. So the force, that means the pressure constant all around. That means here and here within this system the pressure is constant, between this system the pressure is constant, and the surroundings the pressure is constant. That means no any unbalanced force required in chemical equilibrium. And second is mechanical equilibrium. This is the mechanical equilibrium. And second is the chemical equilibrium. That means no chemical reaction takes place. That means there is no transfer of matter from one part of a system to the other due to diffusion and also chemical potential same. Notice that this is the chemical equilibrium. In chemical equilibrium there is no transfer of matter from one part of a system to the other part due to diffusion. The technical terms is diffusion. So we talking about diffusion. So diffusion, a molecular transfer from a higher to a lower concentration. Notice that the molecular transfer, that means here we generally use the is any body spray as like fog, then we spray in a corner of a room, then the higher concentration of that molecules is spread over all around the room. That means the higher concentration travel to the lower concentration. So diffusion is this. And the last one is thermal equilibrium. That means thermal, you know that thermal, that means temperature is constant all around the system. So here it is the main technical terms which is used to define the triple point. So now we talk about the definition of triple point. Was it triple point? So here the definition of triple point. Triple point of a substance is the temperature. Notice that the temperature and pressure at which the three phases, already we discuss about three phases: solid, liquid and gas, of a substance coexist in thermodynamic equilibrium. We talk about the phases, coexistence and thermal equilibrium. So notice about a triple point of a substance: the temperature, there is the temperature and pressure at which the three phases meet about. So here the figure you clarify that figure. XY x axis is notice about the pressure and y axis notice about the pressure and x axis notice about the temperature. So this line denote the temperature and this line denote the pressure. So here this curve is known as sublimation curve, and this curve is known as vaporization curve, and this curve known as the fusion curve. So these note you clear about this figure here and this figure curve here. This region is known as solid phase, this region is known as liquid phase, and this region is known as vapor phase, and this point is known as triple point. And the higher you here look at about here, this is known as critical point. We discuss further the what is the critical point. So with respect to pressure, triple point with respect to pressure, here it is known as the critical pressure, and with respect to temperature, this is known as the critical temperature. This critical, sorry, triple point, this about the triple point, this is the triple point. With respect to triple point, that pressure known as triple point pressure, and this is known as triple point temperature. So we talking about the triple point pressure and triple point temperature. Here you look the triple point pressure and triple point temperature. So at this point, this is the critical point, and with respect to this is known as critical pressure, and this is known as critical temperature. So what about this we clear about? You know that the solid phase and vapor phase makes the sublimation curve, liquid phase and vapor phase makes the vaporization curve, solid phase and liquid phase makes the fusion curve. We clear about that. Solid plus vapor phase is become a sublimation curve, liquid plus vapor will become vaporization curve, that is here, and liquid plus solid is known as fusion curve, that is the here. And so for all substances, sublimation curve and vaporization curve always in positive. You notice, you note down the sublimation curve and vaporization curve. Sublimation curve, this is the sublimation curve, and vaporization curve for all substances will positive, always positive. But in case of fusion curve, it may be positive or negative. You hear, it may be positive or negative. In case of water, the fusion curve negative. You note down, in case of water, the fusion curve negative, because you if you make a diagram like that temperature and this show the pressure, then this is the sublimation curve and this is the vaporization curve, and here the negative curve shows like that about this is the for water case, because this is so negative. You know the water, for the case of water the fusion curve will negative. So and we further explain what is the critical temperature and critical pressure. You know here the critical, so it is the that point where saturated liquid, you know, saturated liquid, that phase, and saturated vapor meet, that point known as critical point. And another definition generally you say that it is that point, that means we talking about critical point, it is that point where liquid line directly changes into saturated vapor line. So liquid line directly change in saturated vapor line. So this is the critical point. And you know that if we increase the pressure, then temperature also increase, and the latent heat at the critical point will become zero. At you look about that diagram, that is the entropy, and here it is the temperature. If we make a diagram like this, then this shows the latent heat, and you know that if the temperature increases here, here and here, then this is the known as the critical point. And here look here, the latent heat will become zero. So note down, at the critical point the latent heat will become zero. So, and the critical temperature equal to 374 degrees centigrade, and critical pressure equals to 221 bar. But we talk about the triple point. As you look here, the triple point of a water, pure water, we take pure water. What is the pure water? What is the temperature for achieving a critical triple point? Sorry, we achieving a triple point, we need temperature equals to 0.01 degree centigrade, and triple point pressure, this is triple point temperature and this is triple point pressure, will equals to 611.2 Pascal. For CO2, carbon dioxide, achieving triple point, we need to temperature equals to minus 56.4 degree centigrade, and we need temperature pressure at triple point equals to 5.2 atmospheric. Okay, and for you have discussed, this is the Hg, the temperature we need to minus 38.8 degrees centigrade, and pressure we need 0.2 megapascal. So 1 megapascal equals to 10 to the power 6 Pascal. This is the unit. So it is all about the triple point, and we explain a very simple, you know that you suppose you stand a tower, this is the tower, and you stand here top of the tower. If you step down any side, if you go any direction, then you goes down, then you fall down. So notice about that, if any person stand at the top of the tower and that person go any direction, then that person will fall down. So as like this, same as like this, the triple point says that this is the triple point. If we go any direction, notice that if you go any direction, that in this direction like that, then we go to liquid phase. If we go in this direction, that we comes down in solid phase, and if we goes in this direction, then we fall down the vapor phase. That means the triple point at that point, in which in any direction if we go, then we reach the solid region or liquid region or the vapor region. So it is, and some discovery point we discuss, the triple point discovered by James Thomson. You note the James Thomson, and he was discovered in 1873, and James Thomson was the brother of Lord Kelvin. We know James Thomson was the brother of Lord Kelvin, and you know that parameter of temperature, degree Celsius and Kelvin. So this is the all about our triple points. Thank you.